All the best.
Hey everyone, welcome to our winter 2023 STEAM in AI graduation. I just want to say I'm super excited to see Ivy's project and what Tanveer and Ivy have been working together. Um, Tanveer, do you want to give a quick introduction about yourself as well as the project? And then we'll let Ivy wow us with what she has done and learned.
Absolutely. It's great to be here. Thanks, Shilpi, for giving the opportunity. My name is Tanveer. I currently am a director of data strategy in Genentech, which is a pharmaceutical company. I've been here for 5 years. Currently, I work in the manufacturing quality space on how do we embed artificial intelligence to create a factory of the future. Outside of work, I like teaching. So I teach at Carnegie Mellon. I teach data science, AI product management, and storytelling with data. And this opportunity has been awesome because I got to work with someone like Ivy, who is such an amazing learner and a quick learner, and she's very proactive, like the best student can that any teacher can ask for. She makes her job
Yes.
really easy. She's very engaged. So it's been great working with her, and I just hope to continue this partnership in the future. I've already offered her help that in your career, whenever you are progressing, if you have any questions, feel free to reach out. So that about Ivy. The project is about money laundering and trying to detect fraudulent transactions. This is a challenging problem for any data scientist, even experienced ones, because the data set, first of all, is huge. But in that huge data set, you have very few, maybe less than 1% of rows that are actually fraudulent. So, how do you deal with such highly imbalanced data sets? And while Ivy was solving it, she faced many challenges that would have made any data scientist say, let me do something else in life, but she overcame all of them. So super excited to see what she has to present.
Thank you, Tanveer, for this. Welcome, Ivy. I'm excited to see your fall STEAM in AI graduation project.
So do I share image or no?
Yeah, it's enabled for sharing. Go for it.
Okay. Oh, can you see it now?
Yes.
Okay. So hello, this is my financial fraud detection model for STEAM and AI. Okay, here. So what is the problem? So we're trying to solve money laundering. So it's mainly an issue because it's usually linked with other types of crimes. So if we can detect it, it's good to uncover it. And then because it has a low reporting rate, because usually the people who are involved can gain money from it, so they don't like report to the government. We need a new way to detect it. And one issue though with trying to detect it is that the data set is very imbalanced, which means that there's very few laundering transactions, and that means we have to do a lot of pre-processing to make the data like usable for models. And this my data set has a mix of categorical data and continuous data. So here they are. Moving on. So I did a bit of data analysis just to find out like different things of the data. So I have here's my hypothesis about useful features, and features I was unsure of. So here we go.
So, Ivy, can you go back on slide 4, please, and explain to us, or one slide behind that? Yeah, so tell us, so you can go a little bit slow. We have time. This is your spotlight. So tell us what is categorical data and what is continuous data, and just walk us through the project as if we are newbies and we don't know anything.
Okay, so categorical data is data that is like non-numerical. So like you have like category 1, 2, 3, 4, etc., that kind of thing. Continuous data is with numerical data, and it's like if you have data from a range of like 1 to 2, then it's all the values between 1 and 2. And so exploratory data analysis is just you analyze the data and you see certain patterns or relationships between the different column or different features, which is what like these things are called, which is like the columns in the data. And so I'll do that right now. So this is my hypothesis. So here are the list of features. So based on like just prior research on the money laundering, I found that I think that the ones that are not useful are timestamped and the account data, because the data set that I'm using, the timestamp is only over a few days. And so there's not a lot of like difference in terms of like time and date that is necessary. So I don't think it's very useful. And then account data is like which account sent it and which account didn't send it. Currency is like what currency was it paid in and what currency was it received in. Payment format is the type of way the money is received, so like credit card or cash. And then the bank information is which bank you're sending it from and then which bank you're sending it to. And so I think that the timestamp and accounts ones are going to be useless or less important. And the more useful features would be currency, payment format, and I'm a little unsure about whether or not the bank would be a useful feature. And so from the get-go, I dropped the timestamp so that it would be easier for me to sample the data. And then for the account one, so one laundering method is called structuring, which is basically you have a large sum of money that you made for illegal means, and then you divide it into smaller parts, and then you send it to like several different accounts, and then that way it's like much harder to detect. And so I checked like which accounts have the most money laundering events, and but then I looked at the number of transactions from accounts just out of all the transactions, and I found that accounts with a lot of laundering events also just have a lot of transactions in total. Like if you look at this first account here, 660, it has 314 laundering events, but like out of the total number of transactions, it also has the most as well. And it's also similar for all these other account numbers.
So how do you identify whether it's a laundering or not? Like it's a small amount, then it's a non-laundering? And if it's a big, how are you identifying that?
Well, this is number of laundering events. So this
And
is
then the second column is number of non-laundering events. So how are you identifying whether it is a laundering event or a non-laundering event?
The data set has a column called is laundering.
Okay.
So that's how you would know.
Okay.
And if I can like, quickly just support that. So yeah, the data set, we have a label, and that's what we train a model to learn based on this. What are the features that are important that differentiate laundering and non-laundering? And then the hope is whenever in the future new data comes that we haven't seen, at that time we can use the same concept to then flag which rows or
Makes sense.
transactions are laundering.
And where did we get this data? What is the source of this data?
On kaggle.com, I think it's made by IBM.
Cool.
So I also looked at the banks, and it also has like similar results. Banks with more laundering events also had just more total in transactions in total, so it might not be as significant. Then here's about the currency. So I thought that certain currencies might have more laundering problem. Another thing, although that's not necessarily the case, but whatever. And then also recently, cryptocurrency has become more common to use for laundering money, and as well as offshore tax havens, which also have like foreign currencies. So, and then I just made a bar chart on the number of laundering events based on the currency that's being received, and the data set has more US dollars, or not, more transactions in US dollar that have transactions, and then more with a euro, and then similar for the payment currency. But then like this doesn't tell us a lot because we also want to, because the data set just might have more US dollars currency transactions. So I also looked at the percentage of transactions in different currencies that are laundering events. So it's the number of laundering events of that currency divided by the total number of transactions in that currency. And so it does, it has a little bit of, or let's call trend, but it's a little light, but yeah.
But it has swapped, right? Like euro is higher in this and USD is second, as opposed to USD being first in the previous slide.
And then the payment format. So certain payment formats aren't ideal for laundering, while some are more ideal. For example, like cash and ACH are different formats you might see laundering in. And so I looked at the percentage of transactions with different payment formats that are laundering events, and I found that the ACH has significantly higher laundering transactions. And also these aren't all the payment formats. Some payment formats just have no laundering events at all. And I see Timview raised his hand.
Ivy, this is great. If you can go back like 2 slides. One more. Yes, thank you. So to me, it makes sense that it's going to be between US and like the US dollar and euros, because I think these are the most used currencies in the world.
Universal, yes.
So since they are already used most, they are right. So it will be good in future. Say if we want to further develop this, where we get other data, trying to normally how is the spread, how currencies are dealt with, and then see if there's a statistically significant difference between this sample that we have and that. But those are future developments. And just one feedback on these charts that I would like to provide is this great. This tells us data, but now we need to tell some stories with that data. So maybe having so let me ask you a question, Ivy. On this chart, what is the key takeaway that you want the viewer to walk away with?
That US dollar and the euro dollar have more transactions that are like laundering.
Perfect. So then what you could maybe do is order it in descending order. So US comes first, euro comes first, others are there, and then maybe drawing a line at what's the highest for the next one, and which is like big, right? And then showing that, see, there is this huge gap, something like that, where you highlight where you want the person to look at and what you want the person to look at, because when we see a chart, everyone sees it differently, represents it differently. So just some recommendations to improve when we put charts on a slide. But this is great. I'm just
And one more thing to add to what Tanvir just said, and this is just constructive feedback we want. This is awesome. We can understand what it is. But if the X and the Y could also have like number of transactions versus number of dollars spent or something. So what is it that the X and Y represent, right? So that also is a good way to help the viewer understand what this chart is all about.
Okay. Going back. So we were looking at how the ACH has many more percentage of transactions that are laundering events. And so, what the hell is it? Oh, don't worry, it's later. Okay. And so then I looked at the the amount received and amount paid. And so I looked at just, this is a box plot of the amount paid and the amount received. I don't know why the y-axis is in scientific notation. I made it with the code, so I don't really know how to, I don't know how to change it, but it's a very big number. It's in the billions. Oh my goodness. Okay. Anyways, and so I found that the outliers has significantly great. There's many outliers are significantly greater than the value at 75% of the data set. And then I also found the distribution of amount paid in laundering events from minimum value to 75%, because if I did it to the max value, it would just be one rectangle on the side. So I had to change the range a little bit. So the data is in this range needs to be more skewed to the right. I don't really know that. So maybe certain amounts of data have more, certain amounts of dollars paid have more laundering event, that kind of thing. And then I also looked at unequal values between paid and received. So if we look here, since this is for the whole data set, the amount of rows in each one is the same. However, you look at the different numbers, they're all different, which means that the numbers in each column are different. And so I looked through all these transactions and I found that it's actually when the number is different, it's actually a different type of fraud. So there's not only laundering in the data set, there's another hidden fraud that's not being marked. That is it's called ACH fraud. It's when you steal money from a financial transaction network. So yeah. So eventually I kept both of the features. And so yeah, and so after I found that the most important features are the payment format and maybe the currency, but I have to do more look into that, as you guys said earlier. And then I make the model.
One thing.
So
So the best thing about this is Ivy had a lot of variables to deal with, and she stuck with two. And that's what we need to do, because how do we simplify the problem? And this is a great skill. Even if there are other data scientists who will work on this, maybe from, I don't know, 20 columns, they'll come down to 10, 12, but she focused on two. So that's great.
So these two, that was her hypothesis. She started with those two. She identified that, and then she could have decided that maybe these two are not the best ones, and then you go back and pick something else, right?
Yes.
and so I make the model. So these are all the methods I'll use, and I'll explain all of them most likely.
Yeah.
Yeah. So the first one I use is the random undersampler and then the SMOT NC. So the undersampler is we apply to the majority class, which would be the non-laundering events. And so it basically chooses random rows of data from the majority class and then it deletes them. And so hopefully, you have your minority class and then it will shrink slowly towards the same size as the minority class. And then the SMOT NC is for oversampling, which basically means generating new data because we have very little data for laundering events. So this type of SMOT that I use called SMOT NC is specifically for a mix of categorical and continuous values. And so before I used these tools, the minority class, the size was 0.51% of the total amount of data. And then after that, I made them so that they are equal in size. Although I did run into a problem here where if I did too much SMOT and then I wanted to make dummy variables, I would run into a memory error and then I wouldn't be able to run the model. So all of my data sets are very, very small. They're only like, I think the largest one is only like 20,000 rows in comparison to the original data set, which was 6.9 million rows. So
Oh,
yeah.
wow. See.
But that's not my problem. That's my computer's problem. Anyways, so and then I also use I used these other ones which I'll talk about later. Also, the dummy variables though are for it's called hot encoding, and it's basically turning the what are they called? The categorical data into numbers. So like you have yeah, I can show on the data set later actually. It's fine. And then I also use the stratified k-fold for cross-validation. That's for checking each different model. And then basically it just splits it into different folds. And then it's called stratified because it makes the distribution of the majority and the minority class in each fold the same. And then cross-validate is just checking between the testing fold and the training fold. And then the precision and recall, I'll talk about when I look at the results. So the first method that I'd use was logistic regression. So it's a method that estimates the probability of an event happening by using the log odds. So you calculate the odds using the probability. It's the wins over losses. So it would be your probability was a decimal number, it would be p over 1 minus p. And then we take the log, because just split the graph, and then so basically you set the log odds into equal to linear regression, which is a constant plus different coefficients against your different x variables, and then you put that in here, and then you work backwards to find the probability, and then there's a threshold of usually 0.5, and then you just change it so that and then you can adjust the threshold, but usually 0.5. And then so if the probability you get from here is greater than 0.5, it's a 1, and if it's lower, then it's a 0, basically. And then, so this is my results. So here I'll explain what precision recall and then F1 score is. So precision is the total, it's how well the model does at not making false what's it called, false predictions, because it's the true positives over the true positives plus the false positive, and then the recall is the it's how well the model does at predicting which of the real values of all the ones, I guess. So it's the true positives over true positives plus false negatives, I think. Anyway, and then the false F1 score is the weighted average between the two. So if we look here, it has a very good recall 1. We're looking at this row called 1 because that's the class that we care about, but we can see that it doesn't have a good precision, and we can also look up here for 0. That means that it misses many of the non-laundering events and has quite a few false positives, which isn't very good. And because it's such a perfect 1, I think that there might be a little bit of overfitting going on with the logistic regression. And then another one I used was this thing called decision trees, which is a tree of decisions. Basically, each decision is like in this table here, table and graph, like it has 2 different outcomes, and then you follow along the tree until you have like a value at the end, and then it will continue to make decisions until a prediction is reached. So that, and then so from the decision tree, it performs very well in all the different metrics, and it has a low number of false positive and false negative. And then I used the gradient boost, which is multiple decision trees, and basically each tree is made based on what you got in the previous one. So you start by predicting an initial probability, which is based on the log odds, and then it takes the difference between the observed and the probability. The observed would be a 1 or a 0 depending on your data, and then you make another tree that will predict the residuals, and then you keep making trees until you lower the residual until you can't lower it anymore, basically. And so my result from this, so I did adjust something while I was doing it. I wanted to save time and my memory, because every time I run a model, it takes up all of my memory. And so I changed it to 8 because the video that I watched explaining gradient boost said that it's usually between 8 and 31 maximum number of leaves in each tree. So I changed it just to the lowest one. And I can see that the values are very similar to what we got with the decision tree. And then I also used a final forest called AdaBoost, which basically is similar to gradient boost. It makes trees that are based on the previous tree that you made, except that the trees that it makes are called weak learners, which basically means that it only has one node and then it goes into it only has 2 outcomes, basically. And and then it makes one. It has a bunch of weak learners to make a one like stronger learner, and it and then it calculates this thing called amount of say to each stump. So each basically takes like a weighted average of like what each stump will say is like the whether it's a laundering event or not a laundering event. And so my results are quite similar, maybe a little lower, but also quite similar. So in the end, I chose to use the gradient boost because it was a little faster, because I was able to find a package called Light Gradient Boosting Model, which is just a faster and lighter method. And then it also had more parameters that I could tune, although I didn't have enough time to tune my model. So I was only able to test out like one different outcome, which was with 16 maximum number of leaves, and the scores that they got at the very end were basically the same. So yeah, and then feature selection. So I also didn't do this because according to my research, PCA isn't very good to use on categorical data, and it's also more difficult to perform feature selection on categorical data. And most of the values in my columns in my data sets are categorical, except for like 2 columns. I didn't do it. And then my conclusion. So my challenges. Every time I had a challenge, it was always a memory error. Every time I faced a roadblock, it was a memory error. I also didn't have the main places where I put memory errors was when I tried to oversample my data, and then the next time was when I finally finished oversampling data, I couldn't actually use the data that I made because it was too big. So I had to go back and make more resamples that were smaller, and then I could finally make my dummy variables. By then, I didn't have enough time, and I also just didn't have enough time because I am in grade 12 and I'm very busy, and I have university applications, and yes, and then improvements. So first of all, I want better hardware, but I feel like that's very impossible because I'm at home. If I had worked, if it was funded by a big company, maybe, I could have more memory, I could have better CPU, I could have GPU support for these, so they would run faster. And I also think that maybe a little more time to work on the project and a little more preparation. I had to learn a lot of fundamental concepts. I'm still taking AP stats, so I don't know all the statistics fundamentals yet. And so my conclusion was that I learned many high-level concepts that are related to data science and AI. I learned how to construct different models, and I spent a lot of time self-learning to be able to finish this. And I don't have and then thank you for listening. Thank you. Oh, and thank you, Tanvir, for teaching me and making this giving me this opportunity. Yes.
Awesome. Great job, Ivy. This is so impressive. Do you also have like an actual model or date, like something to show for the model?
Sure. When I tried to upload it to GitHub, it gave me a 408 error, which basically means it took too much time to upload. So I don't really know what to do about that, but I can show you on my screen.
Okay. Tanvir, can we work with her to get that uploaded?
Yes, absolutely. And just like great presentation, Ivy. And then I loved how engaging you were, how you were super funny as well. And that's a very key characteristic for presenters. So keep it up. Okay. That's awesome. And there was this one slide on which, 1 second, Ivy, before we move on to this, there was this one slide where you showed all the different things that you had used.
Yes.
Starting from dummy variables, which goes into feature preparation, then moving into your SMOT, your random upsampling, downsampling.
That's this one. Yeah.
Exactly. So yeah, you start with dummy variables, then you do your random undersampling SMOT combination. Then after that, you do some k-fold cross validation, and it's important to do stratified because this is an imbalanced classification exercise. We need to make sure that when you create train and test splits, they all have equal proportion. So that was great. You learned that. Then logistic regression, decision trees, gradient boosting, ADA boosting, and so many other models again, awesome. And then finally, precision recall F1 score. How do you evaluate models? And from precision recall F1 score, which one do you think is the most important for our use case?
For our use case, I think it would be recall, because it's more costly if you like miss a one of the cases, right?
Exactly. And even if we have false positives, that's still fine because we are playing it safe. We may flag more transactions and should check whether this transaction is fraudulent or not, but not miss. So that was great. So I think you did a really good job learning so many different techniques.
Absolutely.
And this is just one aspect. We also learned time series and the regression side, which is not being shown in this presentation. So this is just a very tiny portion of what Ivy has learned in this thing. And just to be able to keep up, it was awesome. So great
And
learn.
I don't know if any high schooler who knows so much, who has learned so much, like real actual things that are used in the industry. Like Tanvir teaches his Carnegie Mellon kids, students who are actually from the industry. So kudos to you and Tanvir and the program to be able to bring something like this so valuable. And you're going to get such a big head start when you start college. And I also like the graphics. It feels like, there's. Did you draw these, or it has your
I
represent?
used the most simple slide format because I was rushing, and then I just throw them on to fill the space, because it'd be a little weird if you had just white space there.
But it somehow has a little resemblance to you, like the graphics. Feels like it's like your personalized avatar or something.
Oh, no. Okay. Anyway, I will share the model now. Okay.
Yeah.
Yes. All right. So as you can see here on the side, I have all these files. I originally made these 3 to 5, but they were too big. And then here. The reason why I had them backed up into CSV files is just in case I had a problem and I had to, for example, do something like restart my kernel, which is the thing that runs this whole thing. And because I had to do it a few times to clear my memory, so I saved them onto CSV files so that I could save my progress. And so, like these ones are, the original sample that I made here. So as you can see, this is the original size of what I made. There's 700,000 in this one. And then I would just later undersample that so they'd be equal. But then I had to fix them. And then here, I had to make it like only 14,000. So I spent so much time trying to do these resampling. So I'm a little unhappy about that. Anyways, and then I started to do, so then here is my actual models. So first I loaded my data, and then I made the dummy variables, and we quickly go over, and we go over here, which is the actual model. So I made this, and then I have this, and then I made 2 methods for them, and then I just called all of them. And then here, let me view. So here is basically, I stored all the reports into an array so that I could look at all of them. If I had more time, maybe I would take like an average of them. But anyways, so here you can see all of them. They're all very similar. There's a high one here, there's a really low one here, and then this one's always close to 0.5. So yeah. And then I also did the decision tree, which I call here, and then I also plotted the tree. Ta-da! Although I can't use this image in my presentation because it was, as you can see, very hard to interpret. And then I also have an array for all the results from the decision tree, and then I have my gradient boosting. So here's where I use the light gradient boosting classifier instead. So it's different library than the other ones, which is from the Scikit to Learn. So then just a number of leaves and the objective, and then I have my functions again, and then I called every one of them. It's a long output, and then down here I have all my results, and they're also very similar. And then I did the AdaBoost, which is the last one that I did. And this one, I remember AdaBoost taking the longest time to run. But here are the results. And then I tried to do a little bit of hyperparameter tuning, although I didn't do enough. But then, so I changed the number of leaves, and then I look at the results, and they are literally the same as before. So I think I probably have to change a different parameter. And yeah.
Very cool. Tanvi, do you want to add anything?
Oh, I think I've said enough.
So one thing I heard Ivy say that, she didn't have enough time, but what I feel like you have a lot of great building blocks and you have learned a lot. And I know that this is a very busy college application season for you, and probably some of the hardest courses that you have taken as a senior. But once your application season is over and you want to come back to this, now you have, the fundamentals to keep working on this, and you can now continue your journey on data and AI ethics. So kudos to you and kudos to Tanveer. Awesome job. I'm super proud of you, Ivy. And Tanveer, you too did a great job. It's not easy to teach so many concepts related to data science and artificial intelligence to a young mind. So good job. Good job, both of you. And
Yeah,
congratulations.
we form a good team.
Yeah, and this is a great platform to learn, keep on learning, keep on growing. And Tanveer and I will always be your cheerleaders, and we are here to help. Not just this journey doesn't end with this program, but it's just getting started. So anywhere you need any help going forward, if you need anything, be a part of the community, feel free to reach out, and we'll always be your biggest cheerleaders.
Thank you.
Thank you, Ivy. Thank you, Tanveer.
Yes.
I'm going to stop recording. 1 second.